Alright, so we're going to take notes on inverse trig. So we're just going to talk about what's the difference between using trig and then using the inverse trig function. So we're going to use inverse trig when we are trying to find a missing angle in a right triangle. So we're given the length of two sides, but we're actually trying to find an angle. So we're still going to use the information from trig. So remember SOHCAHTOA, where you have sine is the opposite over hypotenuse, cosine is the adjacent over hypotenuse, and tangent is the opposite over the adjacent. So we're going to use that to help us know which trig ratio to use, or which inverse trig ratio to use. So then we're going to set up the problems like trig, but then we're going to use the inverse functions, which is sine to the negative first, cosine to the negative first, and tangent to the negative first, or the inverse of sine, the inverse of cosine, the inverse of tangent, and we're going to use that to find the angle. Okay, so again, we're going to have to use Desmos to do this. So here's our first example. As we can see, we're missing an angle, but they were giving us two sides. But we're still going to go ahead and set it up. So even though the angle is missing, we don't know what it is. We should be able to do our reference angle. So this side would be our hypotenuse because it's across from the right angle. Then if that's our reference angle, this is the opposite, and then this side is the adjacent. Now granted, there's no information on the adjacent, so we're going to ignore it for now. So what is looking like, we have an opposite and a hypotenuse, so we know that's sine. So we're going to set it up like normal. We're going to have sine of the angle, but the angle is x. So we got sine of x is equal to the opposite, which is 15 over the hypotenuse of 24. Okay? But because we can't put in sine of x into the calculator to figure it out, now we're going to know to use our inverse trig, which will use sine to the negative first. And inside of that, we're going to take the ratio of the sides, the 15 over 24, and that's equal to x. And so now we're just going to put all of this into the calculator, the sine to the negative first, and then parentheses 15 over 24, and we're going to figure out what the angle is. Okay, so let's go to Desmos. So open up Desmos on your split screen so you have that. Alright, so now that we have Desmos open, remember we have to put this in degree mode. So make sure you've done that. So remember, hit that little wrench, hit degree mode. Now we're good. So now we just want to type in sine to the negative first, and then parentheses 15 over 24. So we're going to pull up our keypad. Remember, it's under functions. So here's your sine to the negative first. And then we're going to do 15 divided by 24. And then we can close the parentheses. And so now we can see that our angle is about 38.7. So then if we know this, it's 38.7 degrees is equal to x. So now we know that angle should be about 38.7. Okay? Alright, so let's try another example. In example 2, we have our x, which is in our angle and not on our sides. But so we know this is the hypotenuse, this side is the opposite, and then this side is the adjacent. Okay, so we have no information on the opposite, so we're going to ignore it, cross it out. So then we have an adjacent and the hypotenuse, so we know that's cosine. So now we're going to have cosine of x equals the adjacent over the hypotenuse. But now our angle is x, so again we can't put that into the calculator as is, so now we're going to use the inverse function. So we're going to do the cosine to the negative first, 8 over 11 equals x. And then we're just going to go to our Desmos and we're going to put that in the calculator. So now we're looking for cosine to the negative first. We're going to type in 8 divided by 11 and close the parentheses. And so now that we know the angle x has to be about 43.3 degrees. So here we know this is about 43.3 degrees. let's try another example. So example 3. I'm actually going to stretch, make this picture a little bigger, just so we can write on it. Alright, so again, we know we're looking for an angle, but here, this would be our hypotenuse, because this is our reference angle, this is the opposite, and this is the adjacent. Now, there's no information given on the hypotenuse, so we're going to ignore it. So we have an opposite and an adjacent, which would be tangent. So now we know we have tangent of x is equal to your opposite, which is 20, over your adjacent, which is 37. And because we're looking for x, that tells us we're going to, which is our angle, we're going to use the inverse function. So we get the tangent to the negative first, 20 over 37 equals x. And now once it's set up, let's go over to decimals. We got our functions. So we got inverse of tangent. We're going to do 20 divided by 37, close the parentheses. And so now we know that angle should be about 28.4. So this should be 28.4 degrees is equal to x. So we know this angle here is about 28.4 degrees. Alright, we have 2 more examples. So in example 4, make this a little bigger. In example 4, we have our reference angle is here. So now we know that this side has to be the hypotenuse because it's across from the right angle. This side is our opposite, and then this is our adjacent. Now because we have nothing on the opposite, we're going to cross that off. So now we're left with the adjacent and the hypotenuse, which is cosine. So we're going to have cosine of x equals to the adjacent, which is 18, over the hypotenuse of 23. So now because x is on our angle, we know we have to use the inverse trig. So we have cosine to the negative first, 18 over 23 is equal to x. And now we just want to plug that information into our calculator. So we go to functions, and we're going to do cosine to the negative first, 18 divided by 23, close the parentheses. So we know that angle is about 38.5. So this angle is about 38.5 degrees. It's the value of x. So we know what that angle is there. Alright, last example. So we have a word problem, and so all you'd have to do here is be able to sketch a right triangle that represents the situation and then do the same thing. So in this one, Henry is using a 15-foot ramp to load boxes into the back of the truck. The back of the truck is 3 feet above the ground. What is the angle made between the ramp and the ground? So if I was to sketch a right triangle, okay, so there's my right triangle. We know we have a 15-foot ramp, and the back of the truck would be up here. It's 3 feet above the ground. And so we want to know what is the angle made between the ramp and the ground. So we're looking for this angle here. Okay, so now let's label. So we know 15 has to be our hypotenuse because it's across from the right angle. This side is your opposite, and this is your adjacent. Now we have nothing on the adjacent, so we're not going to worry about it. So now we have an opposite and a hypotenuse, which is sine. So we're going to do the sine of x equals the opposite, which is 3 over the hypotenuse of 15. So because x is in the angle, we're going to use inverse trig. So we have sine to the negative first, in parentheses, 3. That's 3. Let's erase. 3 over 15, and that equals x. Now in order for us to find the angle, we're going to go over to decimals, use the inverse sine function, 3 divided by 15, and close parentheses. And so now we know the angle between the ramp and the ground has to be about 11.5 degrees. and that's x. Alright, so now that's it. And you can turn the video off.